So 9.2, and you'll find the rest of chapter 9 a little different from 9.1. 9.1 was about manipulating those identities that, as you saw, were pretty complicated. 9.2, we are going to use the sum and difference formulas. They are going to be formulas that you will not have to memorize. They will be up on the board for the remainder of the year. You just have to know how to use the formulas. And so that's what we're going to talk about today. So these are the sum and difference formulas. The sum formulas is if we just wanted to add two of our functions together. So I'm going to zoom in on the sum ones, and then let's discuss those. If we have the cosine of two angles that are added together, so that is an alpha symbol, like a little fish. That's an alpha. That is a Greek letter alpha. And then the other Greek letter is a B, a beta. So that's the cosine of alpha plus beta. You're just going to take the cosine of alpha times the cosine of beta. This is going to have to be different than the sign you see here. So it's a minus. And then it's the sine of alpha times the sine of beta. The sine of alpha plus beta is the sine of alpha cosine of beta plus the cosine of alpha sine of beta. The tangent is the formula you see here. I'm going to add one little thing. You can also take and do the sine of what you find divided by the cosine of what you find. So in a problem, if I have been asked to find the sine and the cosine already, I will avoid this formula and I will just do that because I've already been asked to find those things. Now, once we have this sheet filled out, I do want you to take a screenshot of it so you have it in your camera roll, so then you have that to look at. Okay, so we're going to discuss how we use those formulas. Something that's interesting, the difference identities will just take all of these signs and they will switch them. So you'll notice that if you switch the sign here in the front, every sign switches in the back. Okay. So does everybody have the sum formulas written down? Okay, keep writing those, and then we'll switch to the difference formulas. Everybody got those ones down? Okay, here are the difference identities. If you compare the two again, the cosine, whatever's here, is always going to be the opposite sign that we see there. The sine always matches. The tangent will always have a minus on top, or it matches on top and is different on the bottom. Again, you're not going to necessarily need to memorize these formula. You do write them down, please. You are going to have to know how to use them.
Thank you.
Now, why are these formulas helpful? Why are these formulas used? Well, our unit circle is limited by the values on the unit circle. So those multiples of 30, 45, and 60, if they're not a multiple of 35, 45, and 30, 45, and 60, you're not going to be able to find those exact values without some type of calculator. What these formulas do is that takes any two values on the unit circle, and we can add them, or we could subtract them, and so then we get more options that we can find exact values for. So that's what it is used for. These formulas are just going to be helpful as we go through the process of just finding values we hadn't seen before, okay? So if you could take a screenshot of this, you could also add over here that you could write down that this is the sine of alpha minus beta over the cosine of alpha minus beta. I do tend to use that version when I've already calculated the sine and cosine. If they didn't ask me to calculate the sine and cosine first, it is too time consuming to do that. I will just use this formula otherwise. But I do avoid that formula. Tangents are a little bit harder on the unit circle to find those values. Sines and cosines we're a little more familiar with. So I do tend to use this if they've already asked me to find the sine or the cosine. So take a screenshot of that. You want to have access to that as we go through this process. Everybody have that, so now we can move on. Okay, so we've got these formulas. Let's talk about how we use them. It says, use the formula for the cosine of the difference of two angles to find the exact value of the cosine of 5 pi over 4 minus pi over 6. Now, if you do 5 pi over 4, minus pi over 6, we get 13 pi over 12. So 13 pi over 12 is not a unit circle value. So that's why when it says here to find the exact value, you can check. We don't know what 13 pi over 12 is. That's not something we've ever done on the unit circle. So because of that, we're going to use the formula that we just wrote down. So let's write down the formula. The cosine of alpha minus beta, now it has to be a minus here, so we have to use the difference formula, is going to be the cosine of alpha, cosine of beta, plus the sine of alpha, sine of beta. So the cosine formula, if it's minus here, actually does become a plus there. So the cosine formula, the signs are different. For the sine formula, the signs are the same. Now, let's for a moment think about 5 pi over 4. 5 pi over 4 is 225 degrees. Pi over 6 is 30 degrees. So we are technically finding the cosine of 225 minus 30, or the cosine of 195 degrees. Now, 195 degrees is not something on our unit circle. That's why we are forced to find or to use this formula. So the cosine of 5 pi over 4 minus pi over 6. How do we do that? My suggestion always for these is to put it in degrees first. Okay, we can deal with it later, but if we put it in degrees, that's just the cosine of, like I said earlier, 225 minus 30. So into the formula, my alpha is going to be 225. my beta is going to be 30. Okay. My alpha is going to be 225. My beta is going to be 30. So wherever we see an alpha, let's replace that with 225. Wherever we see a beta, let's replace that with 30. Okay. So it's going to be the cosine of alpha, so the cosine of 225, times the cosine of 30, plus the sine of 225, times the sine of 30. Now let's go back to our unit circle for a minute. Your unit circle isn't going to go away the rest of the year. You have to know your unit circle. So if you forget your unit circle, you should have it in your camera roll. You should try to write it once in a while. I'm never going to give you a unit circle on any sort of test. Any quiz or test we take for the rest of the year, you have to have memorized the unit circle. So that's never something I'm going to give you. So this next part, you just have to know. Whether you write it down on a sheet of paper as soon as I give you the test and you use that as a reference, I don't care. But I'm never going to give you your unit circle ever again. It is your responsibility to know that for the rest of the year. Warning, warning. Okay, so let's go back to 225. 5 pi over 4, 225 is the 45 in the third quadrant. That is the point, negative square root of 2 over 2, negative square root of 2 over 2. That's 225. 30 on the unit circle, pi over 6, is the point, square root of 3 over 2, 1/2. Now, if that is something that you have forgotten, again, once in a while, rewrite your unit circle on a sheet of paper. Once in a while, look at that unit circle again. Okay, so now that we have the points, we know what we're looking for, let's fill in the exact values. The cosine of 225 is the x value at 225. That's negative square root of 2 over 2. The cosine of 30 is the x value at 30. That's square root of 3 over 2. The sine of 225 is the y value at 225. That's negative square root of 2 over 2. And the sine of 30 is the y value at 30. That's 1/2. Now, one of the things I really noticed as you were working on identities is your fraction skills are abysmal. You guys can't add fractions. You guys can't subtract fractions. You can't multiply them or divide them. Go back, find somewhere, and think about how you add and subtract fractions. Because as soon as we put funky things in fractions, it blows your mind. Adding fractions, you have to get common denominators. Adding and subtracting fractions, that's where you get common denominators. Multiplying and dividing fractions, multiplying, you just multiply tops with tops and bottoms with bottoms. Division, you either have to do big C over little c, or you have to flip the one you're dividing by and then use the rules of multiplication. That being said, order of operations tells us that we must do multiplication before we're allowed to do addition. So to multiply fractions, just multiply tops with tops and bottoms with bottoms. Radicals can multiply with radicals, non-radicals can multiply with non-radicals. So I get negative square root of 6 over 4 plus negative square root of 2 over 4. And only because they have a common denominator of 4 do I want you to take and write it over one big denominator, 4, and then get your final answer. Many of these, you're going to see square root of 6s, square root of 2s, square root of 3s, weird square roots. That's okay. I want you to leave it. That is the exact answer. Now, how could you check your work? Well, in a calculator, go ahead and put in the cosine of 195. Remember, technically, this is the cosine of 195 degrees. Put into the calculator the cosine of 195. You'll get a funky decimal. Then put in this, I would surround that in parentheses and then divide by 4. Those two decimals should match. If those two decimals have matched, you have done it correctly. Okay, so the formula allows us to find new unit circle values that we never knew before. I don't know what the cosine of 195 is. Now we do, okay? So before these formulas, things like 15, those pi over 12s now come into play. We can actually find some stuff we've never ever found before, okay? So that is our first example. It requires you know the unit circle, and then how can you manipulate fractions? So watch those rules of fractions. I would suggest even going back, find something from 5th grade and do a worksheet about adding, subtracting, multiplying, and dividing fractions. And we might end up doing that sometime, okay? Okay, it's a skill you guys definitely need some improvement on. Okay, so now that first example, it was clearly stated that what the two things we are subtracting, okay? Now let's take a look at example 2 and let's discuss how it's different. When I am asked to find the exact value of a trig function, my brain immediately goes to the unit circle, and I want your brain to go to the unit circle and go, oh, is 75 on my unit circle? If it is, we use the unit circle. If it is not, then we have to think of any two things on the unit circle that either add up to that value or subtract to that value. It doesn't matter which, you decide. It doesn't matter. It can be any two values on the unit circle that either add up to 75 or subtract to 75. Pick them, doesn't matter which ones you pick. I am going to use the fact that 75 is 30 plus 45. If you can use stuff in the first quadrant, we know the first quadrant, and we have it memorized a little better than any of the other quadrants. So I am going to use that. And I am going to use then, this forces me to use the alpha plus beta formula, which is the cosine of alpha, cosine of beta, minus the sine of alpha, sine of beta. So in this particular case, that is your alpha, that is your beta. So I'm going to use 30 as my alpha and 45 as my beta. Now, if you wrote down on your paper the cosine of 45 plus 30, and I wrote down 30 plus 45, the formula will work its way out. As long as those things add up to 75 or subtract to 75, we can use the appropriate formula. Okay, so let's into the formula. Let's stick in an alpha of 35, or alpha of 30, I'm sorry, and a beta of 45. So that would be the cosine of 30 times the cosine of 45 minus the sine of 30 times the sine of 45. Now let's go to our alpha of 30 for a moment. Hopefully without hesitation, you know that the point on the unit circle for our 30 degrees, pi over 6, is square root of 3 over 2 1/2. Our beta is 45. Hopefully without hesitation, you know that on the unit circle, that is the point square root of 2 over 2, square root of 2 over 2. So as you're doing these, you might want to write out your unit circle again for memorization purposes. But you want to have that readily accessible as you go through these problems. Okay. So the cosine of 30 is the x value at 30, so that's going to be square root of 3 over 2. The cosine of 45 is the x value at 45, that's square root of 2 over 2. So I just pulled them from the unit circle. The sine of 30 is the y value at 30, that's 1/2. The sine of 45 is the y value at 45, that's square root of 2 over 2. You will notice that the 195 we did earlier and the 30, or the 75, I'm sorry, that we're doing now looks very, very similar. They're going to all look very, very similar in their answers, okay? Okay, so we get square root of 6 over 4 minus square root of 2 over 4 is the same as the square root of 6 minus the square root of 2 over 4. Now, how can you check your work? You can throw cosine of 75 degrees into a calculator, make sure it's in degree mode. you'll get a funky weirdo decimal. Put this in parentheses and divide it by 4. You should get a matching weirdo decimal. Okay, so what this does, that word exact value means you're not allowed to use a calculator. The only method you can use are the points that we learned on the unit circle. Any questions about example 2? Okay. So example 3, all it's illustrating is that both of these are equivalent to the sine of 15. And it doesn't matter if I chose to do 45 minus 30 and you chose to do 135 minus 120. Both of those are going to get the exact same value. Okay, so let's show you why. Now I'm going to write the difference formula for the sine up here. The sine of alpha minus beta is the sine of alpha cosine of beta minus the cosine of alpha sine of beta. Okay. Now I'm going to utilize that formula twice, and I'm going to prove to you that if you did the sine of 45 minus 30, and I did the sine of 135 minus 120, and somebody else did 225 minus, 240, we're all going to get the same exact thing. Okay, so there are many ways to get the value we're looking for. Okay, so let's do our first one here. Our alpha would be 45, our beta would be 30. Let's just first plug it into the formula. So this is going to be the sine of 45 times the cosine of 30 minus the cosine of 45 times the sine of 30. And if we use our unit circle for 45 and 30, this is square root of 2 over 2. This is square root of 3 over 2. This is square root of 2 over 2. And this is 1/2. We get square root of 6 minus square root of 2 over 4. Okay, now I did that fast because it's almost exactly like one of the ones we did earlier. So I just want to show you that we're going to get the exact same values. Okay. Now, for part B, our alpha is 135, our beta is 120. Okay, so this is going to be the sine of 135 times the cosine of 120 minus the cosine of 135 times the sine of 120. Now, here's my illustration in the fact that our first quadrant is more in our brains than the second quadrant. Even I, who've written out the unit circle probably, 100 times, at least, even I look at those ones and go, okay, wait a second. 135 is in the second quadrant. I got to do that. You know what I mean? I got to really think about it. Where the first quadrant ones, you saw how fast I wrote those out. I'm not going to write these out as fast because I have to think about them more. Okay. Now, both 135 and 120 are in the second quadrant. So the x value, the cosines are going to be negative and the sines are going to be positive. Okay. You with me? Makes sense so far? Okay. So 135, that's the 45 in the second quadrant. This is going to be square root of 2 over 2. This is going to be negative square root of 2 over 2. Okay. Okay. The cosine of 120. 120 is the 60 in the second quadrant. I got to think about it. The cosine is going to be negative negative 1/2. And then here, the sine is going to be positive square root of 3 over 2. Okay, there we go. We got it. See how it took me? It took me more thinking because we're in a different quadrant. And so anytime you have the choice, Try to pick things in the first quadrant if possible. Some things you won't be able to, but okay, anyway. So we get negative square root of 2 over 4. Here, two negatives make a positive, so it'd be positive square root of 6 over 4. We get negative square root of 2 plus square root of 6 over 4. Are these things exactly the same? Yes. Both of them have a negative square root of 2 on the top. Both of them have a positive square root of 6 on the top. Both of them are divided by 4. Okay, you get the same thing. So it's not bad if you look at 15 and go, that's 135 minus 120. I can do that. If another person looks at 45 minus 30, both are correct. You'll see they're both correct. Sometimes one is a little more easy than the other. Okay, we haven't done up to this point a tangent. So if we look at the tangent of this, again, I almost exclusively do things like this in degrees because there's too many layers of thinking if we look at radians. Now, if you're good with radians and you want to keep it radians, go for it. But I tend to switch it to degrees. So I'm going to think about this as the tangent of 30 plus 45. Technically, I'm finding the tangent of 75 degrees. Okay, pi over 6 is 30, pi over 4 is 45. We're technically finding the tangent of 75 degrees. Okay, now the tangent formula is a little funky, but I'm going to write this down for you. The tangent of alpha plus beta is the tangent of alpha plus the tangent of beta over 1 minus the tangent of alpha, tangent of beta. Here's again where your fraction skills are going to come back and haunt you a little bit. Okay, you need to know how to work with fractions. Okay, so first, this is going to be our alpha. This is going to be our beta, as I wrote an alpha. How about that? Okay, anyway, so let's talk about the tangent of 30 and the tangent of 45. Okay, so 30 degrees is the point square root of 3 over 2, 1/2. The tangent of 30 degrees is going to be the y value over the x value. And if we do big C over little c, we get 1 over the square root of 3, which is radical 3 over 3. Okay, so I would suggest don't do that formula until you've done that, when dealing with tangent especially, okay? Now let's do it again for our beta, which is 45 degrees. 45 degrees is the point on the unit circle, square root of 2 over 2, square root of 2 over 2. I hope that isn't a shock to you. The tangent of 45 degrees is going to be the y value divided by the x value. You can do big C over little c, but I hope you realize that anything divided by itself is always equal to 1, so that will reduce down to 1.
When you do big C, little c, which one goes on top and which one goes on the bottom?
I always say it big C over little c to help you remember that. The big C goes on the top, the little c goes on the bottom. Big C over little c will help you. Big C over little c. Okay, so now let's plot the information that we've got. Okay, so we're going to do the tangent of 30 plus 45 is the tangent of 30 plus the tangent of 45 over 1 minus the tangent of 30 times the tangent of 45. Okay, so all I've done initially is I've utilized putting the alphas and betas, the 30s and 45s, in their appropriate locations. Now, every place, I'm going to write it down here so we have it. Every place we see the tangent of 30, we're going to put radical 3 over 3. every place that we see the tangent of 45, we get to put a 1. So 1s are a little nicer for tangents. The 45s are nice for tangents. Okay, so let's plot those in. 30 is radical 3 over 3. 45 is 1. 30 is radical 3 over 3. So this would be radical 3 over 3 times 1. Now, here's where your fraction skills come into play. If we reduce that down a little bit, you get radical 3 over 3 plus 1 over 1 minus radical 3 over 3. That should say radical 3 over 3. That right there. Radical 3 over 3 times 1 is radical 3 over 3. Okay. You can't do big C over little c. You have to have a fraction over a fraction. We have multiple pieces. So here, let me show you how to fix this. So look at all of our denominators here. We only see a 3. And all our denominators here and see a 3. And think about if I took all the denominators I see, which happen to only be 3s, but if I look at all the denominators I see, what is the common denominator between those things? 3. Now, if it would be one of them has a 3 and one of them has a 4, you have to use a common denominator of 12. But think about if I look at all the fractions in the problem, what is the common denominator? The common denominator is 3. And here's the trick I'm going to give you. What you want to do is you want to multiply everything on the top and everything on the bottom by that denominator. Here's why you do that. We do that so we eliminate the denominators in the problem. Okay, that eliminates the fractional components that are within the fractions. So that's a trick you can always do. You can always multiply the same thing on top and bottom, divide the same thing on top and bottom. It doesn't change your fraction because you've technically multiplied or divided by 1. Okay, so we've got to here. Now, here's where your algebra skills come into play. You can't make up your own algebra rules. You have to distribute that to the tops of both of those things. We get radical 3 plus 3 over 3 minus radical 3. Now, every time you guys want to try to cross out a term, a kitten dies. Don't do it. If that makes you realize not to do it, don't do it. You can't cross out those things. A part of a term is not a factor that can be crossed out. It's not a factor. Don't cross them out. You have violated a rule of algebra. That is not a correct thing to do. You guys were trying to do it on that quiz. Can't do that. So you cannot do what you believe is some kind of rule. That's like saying 2 over 2 plus 3 is 1/3. It is not. It is 2 over 5. It is 2 over the sum of those things. So those things are linked and connected. You cannot cross them out. Don't do it. You will be wrong every single time. Okay, that being said, what do you do to fix it? That's technically the correct answer. Are we allowed to keep radicals in our denominators? No. Back in algebra, probably algebra 1 or 2, you learned how to rationalize, hopefully. Put these in parentheses. We only care about rationalizing what is in our denominator. Whatever ends up in our numerator can be whatever the heck it wants to be. But our denominator can't be negative. It can't be a decimal. It can't be a radical. So we fix the denominator only. That's the only one we care about. And we fix it by using the conjugate, which is 3 plus radical 3. I don't care how the top ends up after this process. As long as it's simplified, that's what matters. Okay, on the bottom, that is the difference of squared. A plus b times a minus b is the first term squared minus the last term squared. Use that to your advantage. Don't FOIL it out. It's just the first thing squared minus the second thing squared. It's 3 squared minus radical 3 squared. 3 squared is 9. Radical 3 squared, the radical and the square cancel out. I'm just left with 3. So use the difference of squares. It's a formula. It works. It's on the board. It's always going to be there. It's always going to be a thing. Use it to your advantage. That's why we use conjugates the way we do, because it cancels out a square root because it squares. Okay. Now on top, you do have to FOIL. It's not going to come out as nice because they're the same sign in the middle. They're not different signs in the middle. So let's take the radical and distribute it. So we get 3 radical 3. Then we get plus 3. Okay, so radical 3 times 3 is 3 radical 3. Radical 3 times radical 3 is 3. And we're going to do it again. 3 times 3 is 9. 3 times radical 3 is 3 radical 3. Okay. Now here's where you just got to combine like terms. On top, we get a 12 plus a 6 radical 3. And then 9 minus 3 is 6. And only, again, don't make up your own algebra rules. This 6 has to divide into both things, or it can't divide into both things. So this 6 is only going to be divided out or reduced if both of the normal number pieces are divisible by 6, like this one. Our final answer is 2 plus 1 radical 3, or 2 plus radical 3. Now, how do you check your work? Most of the time they leave it like that, but addition is commutative. You can write radical 3 plus 2 or 2 plus radical 3. It doesn't matter. So you decide. So you can check these in a calculator. If you do the tangent of 75 degrees, you should get the same exact decimal as whatever 2 plus radical 3 is. Okay. So this is going to not necessarily be super difficult as far as, I know that you guys will get that you'll plop it in right. Your algebra from there down, your algebra skills are a little off. I don't know if it's when you took algebra. I don't know if it's COVID algebra. I don't know what the algebra is, but your guys' algebra skills definitely could use some work. Okay. And I've tried to fix you as much as I can, but you got to be careful. Don't make up your own rules. Okay. Follow order of operations. You can only, be careful. Okay. Okay. Tomorrow we will work on these particular examples, and we'll do some of the homework together. But for the remainder of class, if you could start the 9-2 homework, you're pretty much ready to do all of these top 8 that you see there. But there you go. Start those, and then we'll continue this tomorrow.